In this video, we are going to continue to talk about the different gas laws that explain the behavior of gases. At this moment, we are going to be talking about Charles' law. When it comes to Charles' law, understand that Charles' law explains the relationship between temperature and volume. When it comes to temperature and volume, understand that the temperature of a gas is directly related to its volume. So what does that mean? That when it comes to volume and temperature, volume is proportional to temperature. So what this means is that if volume goes up, temperature goes up, and vice versa. And if temperature goes down, volume goes down. Okay, so as long as one property is going in a direction, the other property is going to go in the same direction. Again, this is for volume and temperature. Now, understand that whenever we have a Charles law problem, understand that the temperature must be in Kelvin. So you must convert your temperature units to Kelvin. Now, when it comes to the equation that is utilized for Charles law problems, understand that is going to be V1 over T1 equals V2 over T2. Now remember that for Charles law to be true, we need to be at specifically a constant pressure and number of moles. Because remember, out of the 4 different properties that we have for gases, 2 must be constant in order for this law to be true. Now, as you can see, the last bullet point states, as I mentioned it previously, that in this situation, for temperature and volume, if one increases, the other one increases. So they have the same direction. Okay, so let's look now at a Charles law problem. When it comes to Charles law, as you can see here, the problem states a balloon has a volume of 785 milliliters at 21 degrees Celsius. If the temperature drops to 0, what is the new volume of the balloon at constant pressure and number of moles? Okay, so let's first write the equation that is utilized for Charles law problem, which states that initial volume divided by initial temperature is going to equal final volume, which is V2, over final temperature. Now, when it comes to this, as you can see, we are looking for the new volume, so we are going to be solving for V2. So when that happens, we have to rearrange this equation with algebra. So V2 is going to equal V1 times T2, everything divided by T1. Okay, in order to solve for V2, what I did is that I multiplied both sides by T2. Remember to review your algebra. Now, when it comes to this, even before I start the problem, okay, I must change the temperature units to Kelvin. So understand that when it comes to this, it was given in Celsius, I'm going to change it to Kelvin. How do we do that? In the energy chapter, we learned that temperature in Kelvin is going to be degrees Celsius plus 273. So what that means is that where we have 21, we're going to do 21 plus 273. That's going to be 294 Kelvin. And then for 0 Celsius, that's going to be 273 Kelvin. And now that we change the temperature to Kelvin, we are set up in order to do the problem. So we're going to put all the values given. So V1 is here. And then for V1, as you can see, is 785 milliliters. We're going to multiply that times T2, which is 273 Kelvin, and we're going to divide the whole thing by 294 Kelvin. Now, when it comes to this, remember that your Kelvin units are going to cancel, and your final answer is going to be in milliliters. Remember, here we have a decrease in temperature, so that means that our volume has to be smaller. So when we do this, 785 times 273 divided by 294, it gives me a number that is specifically 728.9. So as you can see, each one of the values has 3 sig figs. So when I round my calculator display to 3 sig figs, I find 729 milliliters as my final answer. The next gas law that we're going to talk about is the relationship between temperature and pressure, which is given by GuyLusaks Law. In GuyLusaks Law, understand that when it comes to this, it's given by the equation P1 over T1 equals P2 over T2. When it comes to the relationship between pressure and temperature, understand that they are directly related. What does that mean? That pressure is proportional to temperature. So remember that in order for this law to be true, volume and amount of gas must be constant. And what that means is that if pressure goes up, temperature goes up, and vice versa. So these two properties of gases are going to go in the same direction. Now, understand that this also has the statement that the temperature must be in Kelvin. So you must convert, the temperature units to Kelvin. So now let's actually explore one of the problems. The image that we have on this slide, as you can see, is just stating that if you increase the temperature, as you can see, the pressure is going to increase. It's just an illustration. But let's actually look at a problem. So, as you can see, here we have specifically a calculation for GuyLusaks Law. And our problem states, a gas has a pressure of 2.0 atm at 18 degrees Celsius. What is the new pressure when the temperature is 62 degrees Celsius? Okay, remember that here we are going to have volume being constant and number of moles of a gas being constant. So the first thing that we need to write is the correct equation, which for GuyLusaks Law establishes that the initial pressure divided by the initial temperature equals final pressure divided by the final temperature. Okay? So remember, in the problem, it is stating that we are trying to find the new pressure. So we're going to be finding P2. When we solve this equation for P2 is going to equal P1 multiplied times T2, everything divided by T1. Okay? Now, when we look at the numbers given, this is our P1 or our initial pressure. Okay, P2 is what we're solving for, and remember, for this, temperature must be converted to Kelvin units. So understand that this 18 Celsius, we need to change to Kelvin units. Remember, temperature in Kelvin equals Celsius plus 273. So when we take 273 and we add it to 18, we get 291 Kelvin. As you can see, the other one is 62. 62 plus 273 is going to be 335. So when we do this, now we are ready to put in the values into the equation. Okay, so P1, 2.0 ATM. We're going to multiply this by T2, which is 335 Kelvin. And we're going to divide the whole thing by 291 Kelvin. Kelvin units cancel. So when we do 335 times 2.0 divided by 291, then understand that here we need to report two significant figures because the ATM has less sig figs than the temperatures. So our final pressure is going to be 2.3 ATM. That if we think about it, it makes sense because the temperature went up. So we expect the pressure to also go up. So understand that in your textbook, we have a summary of the different gas laws, okay? As you can see, the second column state what properties are going to be held constant in order for these gas laws to be true. We have first Boyle's law, which is the relationship between pressure and volume. Then we have Charles' law, which is the relationship between volume and temperature. And lastly, GuyLusaks law, which is the relationship between pressure and temperature.